guys, welcome back. We'll be learning in this video about Linux process management. Like we'll learn entire what is Linux process and how to manage Linux processes. So Linux process is a running program. It's a task that your computer is actually running on. Takes up resources, system resources like CPU and RAM. Key terms to know about processes: PID, process ID, and parent process PPID. PID is unique number for each running processes. And PPID is ID of a process that starts another process. That's a parent ID. And the first process in Linux is init in older systems, and in newer systems it is systemd. It is like a boss that starts everything else. Process is an instance of running program. It occupies system resources like CPU and RAM. There's some important processes in Linux. Well, first is daemon process. Like what are daemon process? Daemon process that runs continuously and requires user interaction. It does not require user interaction. For example, SSHD. It's a daemon process which runs automatically by itself at the background, which handles SSH connection. Let's get into some commands and try to check if what are the process. We can check process if process is running by using this command. I could see these are SSD process, right? These are running. So this is one of the daemon process which is running, and another daemon process is cron, like ps hyphen cron. If we check, there is one process running as cron, right? So these also daemon process. It runs in background and executes scripts at specified interval of time. It manages schedules task. And another daemon process is rsyslog_d, like var log syslog_d, right? Var log syslog. So we have rsyslog_d ps hyphen c this is the command. This is the process which is running, which logs system messages and errors. This is responsible for system messages and errors. And we have another daemon which is running continuously is network manager daemon set, which manages Wi-Fi, Ethernet, and VPN connections. For that, we can check ps-c. There is no process running at present, but this is one of the daemon process which runs in our system. And apart from this, we have zombie processes also. Zombie process also is a process that has completed execution but still has an entry in the process table. This happens when parent process does not read the exit status of child process using wait or wait PID system calls of in C language. The key characteristic of zombie process is it is already terminated but still appears in process list. It gets cleaned up automatically when parent process exists. So let's run one zombie process and try to see if we are able to find it. Let's run one zombie process. So one of the zombie process which I'm running. How do we check zombie process? We can check zombie process by using ps-aux grep. See this process runs for only 3 seconds, right? So it doesn't maybe it has exit code, I guess. So because of that, there is no zombie process of that. This is not a zombie process. So by this command, we get to understand the zombie processes in our system, but we don't have any zombie process right now. We don't have any zombie process right now. So see, we have one zombie process right now, right? So this is the zombie process which runs. Now if we see it, it would have been gone, right? So right, it is for 5 seconds only. It's there for 5 seconds only. After that, it is gone. How to spot zombies? Like we can spot zombies by using ps-aux zombie processes. Grep capital Z. You get to know. You'll get zombie processes. List of zombie processes. Now, how do we handle zombie process? Zombie process does not use system resources. It's not always necessary to remove it. However, if it is too many zombies accumulate, it may affect the system. So let's create one zombie process. Let's check the zombie process is not there. If the process becomes zombie, it will have a Z state and Z state and shows defunct. So right now we don't have zombie process running in our system. So we can identify zombie process using this command also. ps aux pipe grep defunct. We can remove zombie process using like we can get the parent process id. Like there are parent process and the child process, right? So we have to get the parent process id. Let's run one zombie process. Let's work on the zombie process. I have a code here. This is the code which I have. To create parent process and also child process. So let's run this code. For running this code, you have to install GCC. I've already installed this. This is the command to install that. Let's compile the code. Once code is compiled, let's run this. It's running. So now let's see if the zombie process is created. I could see there's a zombie process, right? So let's once zombie process is created, let's try to see the parent process and kill the parent process so that the zombie process is getting deleted. Let's get the parent process. To get the parent process, this is the command. This is the parent process. Let's kill the parent process. Kill the parent process and then let's see. Let's check if zombie process is there or not. Zombie process is gone now. So that's how we kill the zombie process. Like we delete the parent process. We kill the parent process, and the zombie process will also be gone. Process will not cause any harm, but it will not cause any harm, but it may affect the system. Like if too many zombie processes accumulated, will affect the system. So we have created one zombie process and we killed it. We killed it. We removed the zombie process as well. Once that is done, let's how do we prevent zombie process? Like preventing zombie process before creating itself. We can prevent zombie process using this command. This will not create zombie process at all. So this no hub, it will create another shell, and it will try to create another shell, and that's how it will see this one will remove no hub will ensure that process keeps running even if you log out. No hub will ensure that process keeps running even if you log out, and this one will remove from cells job table, preventing zombies. Let's try some other. See, zombie process is not getting created, so this will not allow the zombie process to get created. Okay, we'll wait for this command to run completely. For 100 seconds it will run. So 100 seconds it will run sleep command. So let's check if it is creating zombie process or not. Each and every command which we run, it is a process in itself in Linux. So that's how it is. Let's wait for 1.5 minutes so that let's check. This will not allow to create zombie process. So this command. So let's check what's happening. So this is the process ID. Let's see what happens. So that's not the process ID actually. So let's see what happens now. Um, in more than in 1 minute. So let's see. Let's use Control C. That's done. So it is done. So let's check process. Here is the process, but it is not running. So it is just there idly, but it is not running. So it's not a zombie process. Zombie process, we don't find any zombie process as well. That's also idle process, that's not running. So yeah, so let's move on and let's try to get the host name. Like we can run a command to get host name. This is the command to run host name. We get host name, right? So to get bash shell process ID, this will give bash shell process ID. This shell process ID it is giving, and I want to check the parent process ID. So let's check parent process ID. This is the parent process ID, and this is the shell process ID. So yeah, now let's check how do we search process by name. We can search process by name, right? ps hyphen c bash. If I do, it will search processes by name or sshd. It will give all processes by name. You can find process by directly also, like pid of bash. If I give, it will give the list of processes with this name. Now let's run a process and check if it is running. It is running, right? So we are checking, right? So by running the process, we are checking the process running. Let's install cron shell and z shell also in our laptop, and let's install that. We'll be using that. What is process forking? Process creation, like process creation. Forking, what is forking? Forking is a new process. When a new process is created, it's a copy of parent process. Like it's a copy of parent process. Like when a new process creates copy of parent process. Forking allows multitasking in Linux. Let's do an example. Now echo, it will give present directory, parent shell, parent shell, parent shell process ID. Let's do bash echo. Let's understand what is forking. Uh, Forking means copying the present process. So it allows multitasking in Linux. You can let's do an example. Let's check the current shell process ID. This is how you check the current shell process ID. Let's start a new bash shell forking a child process. Like let's start a new bash. It launches a new bash, but 55526 will be running in the in the background while new shell bash has been created. So let's check. Let's run. we have new process ID created. This is the new process ID, and the parent process ID is of the shell is this 55526. That's the parent process ID of the original shell, and it confirms that 60184 process has been forked from original 55526. It's been forked by 55526 process. Uh, let's use this command and check. This is the newly created bash shell child process. These are child processes which are newly created, and this is the original. This is the original process which has been created by original cell, and remaining two processes are running inside the shell. These two processes are running inside the cell, and this is running inside the new shell. These two are running inside the new shell. So inside the new shell. So let's check PS tree, and then let's see PS tree process ID. Let's give process ID. Let's give $. So this is the if we check this is the this is our new shell process. This is the command which this is the command which was run inside the new shell. This is a new process, and this is the command which was run inside the shell. Let's exit and check if the process IDs are same. Exit, and let's check the same commands. The process IDs are different here. See, if you see, this is inside the process. Now this is inside this bash shell, but this is outside of the bash shell. You see the process IDs are different here. This group PS this command will true. It is different here. So this is the parent process ID, and this is the command which is running inside the shell. So this is the command which is running inside the shell. This is the overall understanding of how we can fork a process out of a process inside a shell. So this is how we fork a process inside a shell. How do we check list of running processes? How do we check that? You can check that by using ps fx. You can use ps hyphen ef also. Ps hyphen ef also. See, this is also a process now here. You see, this is also a process here. Each and every command which we run, it is a process in Linux. How can we grab specific processes? We can grab specific process using pgrep bash pgrep sleep. This is how we grab specific processes. We can view processes in tree also by using ps tree. Ps tree. If we it will give in tree format. Will give all the dependency process which are under the process, like under like if I see uh, this, if I see like system D, under system D, these are all the processes which are running under system D. If I see an SSD under SSD, these are the processes which are running under SSD. If I want to know the process ID also, you can use ps tree hyphen p. Will give it the ID, process ID also. Want to grep any process, you can use ps hyphen p grep. I want to grep bash. So that's how you grep particular process. You can grep it. You can also grep, you can also get process by username also, like ps tree hyphen p hyphen u. If I see there are like two processes running inside like there are many processes running inside Ubuntu. This is the main process, and under this process, these are the processes which are running under SSHD process. How do we check process running in the background? Let's run a process in the background and let's check. This is the process ID. We check it by jobs. This is the process this is the process which is running, or we can check ps hyphen c. Okay, so we basically ps hyphen c bash, it is of no use, but we basically we check it by jobs. If we check jobs, it will show the process which are running in the background. How do we kill a process? Like, how do we kill a process? ps hyphen c. Let's kill a process by using by finding the process and then by killing the process. Terminated, yeah. So that process is terminated, right? So that's how we kill the process. Now let's understand signals. There are some of the signals in Linux. So these are process signals which are there. 64 signals. There are 64 signals which are there. So out of which some of them are useful. I'll talk about that. This this what this will do is this will reload the configuration file. Like, tell systemd to reload the configuration file. Let's create a process. Let's do a graceful shutdown of that. We can forcefully kill also. We can create a process again. You can forcefully kill by using -9. We gracefully terminated a process and we forcefully killed the process here. And we can stop the running process also. Like, let's create a process again and try to stop it. This is one of the other signal which we have. stopped. For resuming of the process, you need you should have 18 signal for resuming the process. It is resumed, right? So, or you can use this also. You can directly say stop. I guess we can directly say stop also and continue also. It will work, but I don't know why it is not working here. Let me check. Let's create a process and try to stop it. Just stop, right? So we can continue also. We can use cont. That again run. So that's how we stop and start the process, and that's how these are some of the signals which we have in processes. Like we can stop, we can start, and we can kill, we can gracefully terminate, or we can restart the configuration file. So these are some of the signals which I've displayed here. You can use it your you can do all the signals which are there. You can probably do it. How do we monitor process real time? We can monitor process real time by using top command. If we don't have any process ID which are stopped, zombie also we don't have. 123 process IDs as processes are sleeping. One is running, that is system dis, and this will also give the process CPU and memory information also, like which process is consuming how much memory and how much CPU. Let's understand the process. Let's understand the process and process IDs. Parent and child processes. Like if we have this, check the parent of the process. Like to check the parent of the process, you need to run this command. Who is the parent of this command? To this, who is the parent of this process ID? If I check this, is the parent ID is 1. So system D is the parent ID of that process. And if I check some other process, this is the parent of this process, and probably I guess this is the parent of this process. That's how the hierarchy will follow. How do we know if how do we know if a process is parent or child? Like how do we know? The parent creates spawns other processes, and child process, it is created by another process and does not create its own process. Like if I see, if I check bash, like it has many processes which are under this, right? So it is the parent process. Like this is the parent process, and under this, these are many other processes which are created under this. So this is how we find out. But how do we find out if child process of a specific parent? Like pgrep -p parent id. Let's give parent id. Like under this is the child of, this is the child process of this. This is the parent process of this and 47194. Where is it? So these two processes are under this parent process. So that is how we find out. How do we check if a process parent or not? How do we check? We check by this command. Or we can check by this command. This is not a parent process because parent process is this, and this is the child process. So that's how it is. Yeah, this is a normal process, and this is the parent process. That's how we understand that this is the parent process, and this is the normal process. So how do we check if a process is orphan? Like if a process has become orphan, who it will be adopted by system D. How do we check? Let's run a process and then try to see if it is adopted by system D or not. Let's run a process. Let's check his parent. Who is the parent of this? We check this is the parent, right? Let's kill parent and then let's see if it is adopted by system D or not. It has become orphan. Orphan process will be adopted by system D. Let's check again. We see this has been adopted by system D process. It has become orphan and it is adopted by system D process. We have already checked like if a process becomes zombie, right? So this is one of the command. This is one of the command which by which we can check if the process become zombie. The output shows Z. So the whatever shows in Z, it is a zombie. So we don't have any zombies still right now, but this is the command to show. This is the command to get zombies in our system. Now let's start the background process. Start the background process. Let's check jobs. Yeah, one background process is running. How do we see all background process running? So we can check by this. These are all background processes running. So these are all grabbing by sleep. So these are all the background processes running in our system. Turning background process to foreground. Like how can we do that? Let's create a process. Now this is a process. This is a process we have, right? So what's the job ID? This is job ID, right? So let's turn to foreground. Let's resume it as background again. Created a process ID, and let's try to move it to foreground. Control Z, then background again. So that's how we get it. So if we check the jobs, like these are the two processes running. That's how we move between the processes. How do we check all stop processes? Like how do we check all stop processes? We check all stop processes using this command: ps grep capital T. If we give this command, it will give all the processes which are stopped. We can start the process by resuming the stop. We can resuming the process by that signal, right? So one signal is there, right? What's the signal name? So signal name is kill. Let's resume this process by using this command. No such process. This is the process which is running. So it's a default process which runs. So it's not one of the process which runs by us, which is run by us or anybody. This is complete about the process management in Linux. So I guess somewhat you have understood and somewhat I was able to explain. If you really like the video, you can please subscribe to the channel, and you can please like the video, and you can share it to your friends as well. Maybe my explanation is somewhat here and there, but somehow I was able to cover whatever I know. I was able to cover. I've written a blog around this. You can follow the blog also, and you can read the blog as well. All these comments I've put it in the blog. You can use the blog to for the comments. Yeah, thank you for watching the video.